Hello and welcome to a recap for this CodeBuddies.org live code session. CodeBuddies is a global community of code learners who help each other through conversations on Slack and peer-to-peer organized study groups and virtual hangouts. Today we've been working on the GeriLife project. GeriLife is an open source tool designed to increase well-being. It's used in elder care facilities, primarily in Finland right now. Our software looks like this. Essentially, residents live in homes and have activities and their personal needs coordinated by caregivers and volunteers and family members who visit the home. We realize that on a daily basis it's really difficult to know person by person or resident by resident who's been outside recently, who's done some sort of well-being activity like art or music, going to a concert. So we wanted to create a tool to help bring that awareness, make the invisible visible. Without going too much into what the platform does, it essentially gives you different data views of these kind of shared activity logs, different facets, looking at it from different angles, looking at resident by resident, if they've been recently active, or overall the home on average, recent trends in activity level among residents, individually what types of activities the residents prefer, or group-wise, what types of activities are most often conducted in a particular home, and who are the main people coordinating the activities. Is it staff or volunteers or family? So that's how the software has been built over the last few years. Today, we extended on an idea where we need to know more than what's going on right now. We need to know what's happened in the past. So we built this historic reporting ability where you can look at previous months. These date labels are a little bit confusing. It's just the way that Plotly is automatically rendering them. But in any case, these are first day of each month. For some reason, it's using the last day. But you can see the trends and activities. And we wanted to see not only at the individual home level, but for the whole system, because there can be dozens of homes in these larger care communities with hundreds of residents. So we were able to reuse a lot of code, and the chart's basically the same and has the same quirks about the date rendering. I can dig more into that later, but it's not a deal breaker. And in fact, it's localized, which is really nice. So Plotly is doing a lot of the work for us. It has some imperfections like anything, but overall it's very solid plotting framework. Probably one of the best ones I found in the JavaScript and in general the data visualization ecosystem. Okay, so let's take a look at the changes. So we have this navigation bar across the top. We added this link here. In order to do that, it's essentially just a list item that links to a named route. We call it a report. I decided to go with the singular for now. Since we just have one report, we can pluralize it later if we decide to sort of somehow create new reports here. And then we localize the link text. Right now I only have the English localization, so we'll have to get some help from Mario, my partner, to get this localized into Suomi language, Suomi kieli. So once we've got this link set up pointing to a named route, we just essentially tell Meteor, or what's the name of the router we're using, Iron Router, that when something comes into this path to render this report view, and this route here is named report. So keeping things pretty consistent. Again, I can change that if we need to pluralize it. So the report, every view in Meteor has a associated template and some JavaScript. So we've separated our sort of structure from our logic, and we've done that along the lines of HTML and JavaScript. But it's not just about separating HTML and JavaScript, it's about separating structure from logic, separation of concerns. So it follows that pretty clear. It gives us a declarative language, HTML, to say what the page structure should be. So we have a header, which has been localized, and we have an empty div here that's going to hold a chart in a moment. We have some logic that's more procedural in nature, although somewhat declarative. We're trying to write our logic in a declarative way. And essentially what happens here is that when this template is created, before it kind of renders out, we're going to start working right away. We're going to create a reactive variable, which we'll see how it's used in a moment, but it's essentially going to be a placeholder for this data to come in. We're going to call to the server and get this chart data kind of cooking on the back end. It's pretty quick, but it's got to aggregate that data, and once it comes back from the back end here, or we're going to run this function and pass it in, and basically just update this reactive variable here. Now this all happens very quickly. The onCreated will quickly go to the onRendered callback. So inside the onRendered callback, we're going to be listening for this data, for this reactive variable to change. And whenever this reactive variable changes, it'll trigger this this whole function to run, this whole block here. It's going to run automatically once. So we're going to check for that reactive data, the activity data, and we're going to make sure it's not empty, because essentially, like I just said, this is going to run at least once, so it could be running with just a freshly instantiated reactive variable. Before we go further in this code block, let's take a look at how this activity data is being generated on the server side in this get monthly aggregated activities method. So this method really draws from get monthly aggregated home resident activities, as I showed previously, that each of the homes has this same report. So I realized there was some duplication there, and I could just build on that. But basically, we're just going to get all of the activities. So we're finding and fetching all activities for the system ever. And we annotate those activities to add the activity name in human language, I believe. And these we don't localize. These are entered into the system by the end user, so they should be localized. There's not a translation interface for these. And what that allows us to do is to group by or aggregate these by the key, these activity labels. And so let's take a look at this. So annotated activities is up here. We just get all the activity types, which are these strings. They're entered in the settings page under activity types. You can just add another one, give it a name, and essentially what we're doing, annotating activities. We're basically adding the label here. I wrote this code a while ago, so I really have to, I didn't write it today. But we should be, okay, we created this dictionary to look up the name when keyed by ID, and essentially we're looking inside this dictionary for the activity type ID and getting the name back and adding it to that activity. For some reason I didn't I didn't do anything with this facilitator role. We didn't need it in any case. Okay, so let's drop back down here. So once we've annotated these activities, we're going to nest them, which is basically an aggregation. So let's take a look here, and this is a little bit more detailed, and I did work with this, so it's a little fresher in my mind. But essentially, we're using D3 nest, and we're first looking at the activity type name, which is what we got earlier. And then we're going to do a sort of a date trunk to get the start of the month. So this should be the first day of the month, and converting it back to a JavaScript date. So these are keyed by activity type and in month. It's in, twice nested aggregation, and we're going to roll them up to get the count of activities, which is the length of the array, and then the number of minutes, which is basically summing all of the minutes in there. And just returns those. So that's the main thing. And since both of these at the home level aggregated and global aggregated levels are basically doing the same thing. We're able to refactor it so we two method calls to those same methods. Pretty nice. And that returns it back to the client. Okay, so that was a little bit of the more kind of dense code. Luckily, I didn't have to wrestle with that too much today. It was already written for me. I just kind of refactored it. So once we know we have some data back, we're just going to render this chart. So we're going to look at the data, and for each category in that, so there's basically 6 categories here, we're going to create a trace. And a trace is basically one time series or one chart sort of element. You can have multiple traces in a chart, and they can be of different types. You can mix bar chart with line chart with scatter, for example, if you're drawing a regression plot or something like that. It's pretty powerful. So each of those is just called a trace. And for each category type, we're creating a bar trace. So we have multiple category charts, each with its own trace. And Plotly does the kind of combining for us. For the X, we're just looking at the month, the date value, casting it back to a JavaScript date, because I think it's serialized in JSON, and so we have to, in the client, get it back in the proper date data type for Plotly. I wish I could figure out a little bit better how to do these, just to name the month and year. But anyway, Plotly's automatically handling these labels for us, and I'll just let it be. On the y-axis, we're looking at, right now we're looking at activity counts. We want to be able to toggle between activity counts and activity minutes, but just started with activity counts. And we return the trace. So essentially we're creating chart data is an array of these traces. For the layout, we just specify the chart title and the y-axis title and run those through our sort of internationalization or localization process here. We also set the chart locale so that when that locale changes, which is handled by this library, the dates will be localized on the chart, which is really handy. And we just told Plotly to now look for this DOM element, render the chart with this data, layout, and locale. That's it in a nutshell, and I've had a pretty overall good experience with the way Plotly works. It took a little bit of getting used to, but I think it's pretty well designed. It's also it works in multiple languages, so you can use Plotly from Python, JavaScript, R language, and several others. So it's really worth checking out. One of the problems I've encountered in sort of the data visualization ecosystem, particularly among JavaScript charting libraries, is a lot of them are very half-baked, either missing really important chart types or sometimes really awkward APIs. The APIs are all over the place in terms of some of them are more declarative, some are more data-oriented, some of them you have to do contortions to get the data into the right shape. I think Plotly straddles a good balance of usability and good high-level design. It's also very comprehensive. It offers a lot of chart types. It's reactive by default, and it's under continuing maintenance. There's a lot of things in JavaScript data visualization ecosystem that are not very well maintained, maybe a little bit on the borderline of being abandoned or clearly abandoned. So anyway, I really recommend that you check out Plotly if you're interested in data visualization. And we're trying to maybe use it more heavily in our project as well. We've got, I think, 4 visualization libraries in work or sort of involved in this project right now, and we'd like to kind of maybe just run with one of those, 1 or 2. There's just different things, like Plotly can do scatter plot with regression line, again by combining different series. It can do these bar charts. I'm not sure that it can do the calendar heat map, so we'll have to take a look at it over time. But anyway, again, this has been a CodeBuddies.org hangout, and I thank you for your time and have a great day.